Hello, Pre-Cal scholars, and we are getting rolling with Chapter 7 review problems. The problems that I'm going to do in this video are to help you in preparation for your homework that is currently available on MyMathLab right now. So check the due dates on the calendar on MathLab. All of these problems are review, like I said, so we're just going to get started. And of course, I want to remind you straight away that we're simplifying here. And when we simplify a rational expression, we need to remember the FFCC rule, which is you must first have a factoring frenzy before going cancel crazy. We will also be looking for domain restrictions, variable restrictions on these problems. So be on the lookout for those when you're doing the homework on MathLab. And just a reminder to please do all your work in your notebook that I ask you in the info video to have. So please be neatly labeling everything, dating everything, keeping up with everything, so you have a nice portfolio at the end of all this. And hopefully we'll get to see each other in the classroom and I'll be able to take a look at all of it. So here we go. So first of all, let's factor everything. So when we factor the numerator here, minus minus, so one's going to be a plus, one's going to be a minus. So this is going to be x minus 5, x plus 1. There's positive 1. There's negative 5. That's what yields the negative 4x middle term. That's our numerator. Our denominator, x plus 1, x plus 5, plus. So right away, before we cancel anything, let's go ahead and say what our domain restrictions are. X cannot equal negative 1 or negative 5 because both of those numbers would give us a 0 in the denominator, and we cannot do that. So if we want to give the domain of this particular expression, we can say that it's all real numbers except those two. So that'll be negative infinity to negative 5, union, negative 1 to negative 5, union, and then, I wrote it backwards, and then negative 1 to positive infinity. So forgive me for making mistakes. I'm rusty because this is a whole lot of excitement going on. So from here, let's do some canceling now that we have everything factored. Obviously, the x plus 1s are going to cancel as a unit multiplier. So we get a simplified expression of x minus 5 over x plus 5 for our simplified answer. So we're going to see some of those in our homework. We're also going to see some where we need to multiply, but before you start multiplying, we're always going to factor first because this could get real messy having to multiply everything together. And since we want to simplify, then let's please factor everything first. We'll also list the restrictions on the domain here. So in the numerator, we have t minus 1, t plus 1, as that is the difference of two squares. Then we have a prime factor of t minus 2 on the bottom. T squared minus 3t plus 2. Minus plus is going to give us a minus minus in both factors. That's going to be t minus 2 and t minus 1. Plus plus will be plus plus in the factors. T plus 3, t plus 1. So now that everything is factored, we can give the domain restrictions. I won't worry about interval notation here. We're just going to list what t cannot equal. T cannot equal 2 or negative 3 or negative 1. Those are the restricted values. And now that everything is factored, we can start canceling. So we can cancel a t minus 2 with a t minus 2, a t plus 1 with a t plus 1, and we are left with a simplified answer of t minus 1 quantity squared over t plus 3. No need to multiply it back together. Simply leave it factored as t minus 1 quantity squared. That's your simplified result. Those are your restricted values. Now, things get a little bit more interesting when we bring about the whole idea of division. So this entire quantity is being divided by this entire quantity. Therefore, we want to look at the factors of this expression, this one, and this one in order to find the restrictions on the variable, because this is the divisor. So that's why we even have to include the y squared minus 4. So factor everything, and then we will also change the multiplication by a fraction to multiplication by the reciprocal. So that's going to be y plus 2 over. Let's go ahead and see if we can factor this little guy. So it looks like it's going to be 2y, y, that'll give us 4. This will give us 1. 4 minus 1 is where we get the 3. So minus, then plus, changing the division to multiplication by the reciprocal. So this expression, y squared plus y minus 6, is coming up to the numerator. So that is going to be y plus 3y minus 2. The y squared minus 4 is, of course, the difference of squares. Put it on the bottom since we're multiplying by the reciprocal. Okay, so let's stop and let's list all of our restricted values. Y cannot be. So remember, we're looking here and then in both of those. This first factor would yield negative 1/2. The second one, positive 2. This one, negative 3. This one again is positive 2, it's already listed. This one again is positive 2, it's already listed. And then finally, negative 2. So there's what y cannot be equal to. So now that everything's factored, let's start canceling. So a y minus 2 with a y minus 2, y plus 2 with a y plus 2. And that's everything. Leave it all factored. There's no need to multiply it back together. Y plus 3 in the numerator. In the denominator, 2y plus 1 times y minus 2. That's your simplified result. Those are your restricted values. So moving on to simplifying with addition or subtraction. Remember, when we're doing addition or subtraction, we need a least common denominator, also known as a least common multiple. So we're going to be factoring if necessary. Not necessary here because these are both monomial expressions in the denominators. But in this first problem, we have something very familiar, a binomial and a binomial, but this binomial is, of course, the difference of squares. Probably the trickiest part of this problem is that minus sign right there. We have to remember to distribute it. So the first fraction, 2 over n plus 4, we're going to be using a unit multiplier in just a minute to deal with that. We'll deal with a minus in just a moment as well. So n squared over, and then this n squared minus 16 is n minus 4 times n plus 4. So think about these problems as the what's missing problems. So this denominator has an n minus 4 factor as well as an n plus 4 factor. This one is missing the n minus 4. So we need to multiply, you got a marker? The denominator and the numerator by n minus 4, because that is your unit multiplier of 1. Remember, we're not changing the value of the fraction, we're just renaming it. So this turns into, when I distribute right here, negative 2n plus 8, and then this is not missing anything, therefore we can just let that n squared be negative. So minus n squared all over the common denominator, n plus 4 times n minus 4. Now, it would definitely be best to put the numerator in standard form, which is just going to be in descending order. And I'll also take out that -1 that's right there. So -1, and then n squared divided by the -1, so that would be positive n squared, and then plus 2n, and then minus 8. I'm thinking this numerator is probably factorable, and I do believe it is. Still over our common denominator here. So I'm going to squeeze in on the bottom of the page here. So we've still got the -1. Factors of -8 that add up to -2 are going to be a +4 and a -2. So -1 and then n plus 4 and minus 2 all over n plus 4 n minus 2. And let's not miss the opportunity here. We have domain restricted values. So n cannot be a -4 and a +2. Remember, give your restricted values before you cancel anything. Because now, when I cancel, whoop, I'm about to make a mistake. And Matt Barnes is not here to yell at me. So, n plus 4's cancel. So we end up with -1 times n minus 2 over the n minus 4. So this is our simplified answer. Leave it factored. Factored is best. That's easiest. Our restricted values, n cannot equal -4 and 2. Let's do it again on the right. As I said a few minutes ago, these are monomial expressions, so no need to factor here. We just need to ask what's missing. Well, what can I multiply to 4 to get to 8? Multiply by 2. So times 2 times 2. What else is missing? Well, this has 3 powers of x. This only has 1. So we need 2 more powers of x. We'll just squeeze them right there. And then we're also missing 2 more powers of y. So that's going to give us a common denominator of 8x cubed, y cubed. 4 times 2 is 8, x times x squared, x cubed, y times y squared, y cubed. Then onto the bottom, 3 minus 2x squared, y squared. Now, we've got multiple variables here, so in this situation, don't worry about any restricted variables. Obviously, x and y can't be 0. That's pretty much it. Okay. Again, we want a common denominator. This time our variable is a single variable, so we'll be looking for restricted values here. So first of all, factor both denominators completely. So first we've got 4 over x minus 5 times x plus 5 plus 6 over plus plus, so this is going to be x plus 5 times x plus 1. So we need a common multiple. So since we need a common multiple for both denominators, basically everybody's got to have a representative and we just need to fill in what's missing. So this guy's missing an x plus 1, so we're going to multiply top and bottom by x plus 1. This guy's missing an x minus 5. And then from there, we're going to use the distributive property in both of the numerators, and then we're going to combine like terms. But leave the denominator factored. So this is going to be 4x plus 4 plus 6x minus 3 all over x minus 5 times x plus 1, or x plus 5 times x plus 1. So we've got x may not equal 5, -5, and -1. Those are restricted values. And then our simplified expression here, 4x plus 6x is 10x. 4 minus 30 is -26. Now, we could take out a 2 out of that numerator, but take a look at the denominator. Nothing's going to cancel if we take out a 2, so we can just leave it 10x minus 26 over x minus 5, x plus 5, and x plus 1. That's your simplified result. Simplify these complex fractions. Remember, a complex fraction is just a fraction over a fraction. And anytime that we are able to eliminate fractions is always a good thing. So in checking out this first problem, we've got 1 over 1, 2 over x, 4 over 1, and 6 over x. This problem can be easily dealt with if we multiply both top and bottom by x. So x over x is equal to the unit multiplier 1. So if we multiply by x over x, it does not change the value, but it is going to dump all of these fractions. So distribute, 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 distribute. This is going to give us x times 1, which is x. 2 over x times x, the x's cancel. That's plus 2. 4 times x, 4x, minus 6 over x times x, minus 6. We can factor the denominator just for the sake of factoring here. Nothing is going to cancel, but we can more easily see that x may not be positive 3/2. This is your simplified complex fraction, and this is your restricted value. Let's do it again with the next problem. So once again, we've got a fraction divided by a fraction. So if we get a common denominator here for every single term within the complex fraction, that common denominator would be x times x minus 2. So that's one way to deal with this problem. That's what we did in the first problem. However, let's take this problem and let's look at it in terms of pieces. I know that sometimes people like to go old school, so let's do that. Let's deal with just the bottom. So if we're dealing with just the bottom, we would transform it, first of all, put that little guy over 1, and then multiply it by x over x, we end up with 2x plus 1 all over the common denominator, x. Well, if we do that, then we can think of this as one single fraction divided by one single fraction, and we can go old school. 1 over x minus 2 divided by x over 2x plus 1. And division by a fraction will turn into multiplication by the reciprocal, 1 over x minus 2 times 2x plus 1 over x. And now we can multiply together. 1 times 2x plus 1 is 2x plus 1 over x times x minus 2, which was the common denominator that I mentioned earlier. So that's a second way to do this problem. From here, your restricted values, x cannot be 0 or 2. There you go. Simplifying complex fractions. We got a couple more here. First one, very simple. What's the common multiple, least common multiple of 3 and 9? Obviously, it's 9. So let's multiply everything by 9. Multiplying top and bottom by 9 over 9. Distributing the 9 through. 9 plus 2/3 of 9 is 6, and 4/9 of 9 is 4. We end up with 15/4. Easy. Again, we see the common denominator. Go ahead and use it. Let's multiply everything, top and bottom, by x plus 3 over x plus 3. So, on the top, x plus 3 times 5 over x plus 3. The x plus 3's cancel. We end up with 5. To the bottom, remember this is getting distributed to both of those. So 2 times x plus 3 is 2x plus 6. And then 1 over x plus 3 times its reciprocal is simply 1. Simplified answer here, 5 over 2x plus 7, which would give us a restricted value of 7 halves, or excuse me, negative 7 halves. Oh, as well as negative 3. Good thing I brought my handy dandy correction tape home for when I make a mistake. Look at the original problem. X cannot be negative 3. Last problem for this introductory video. We will also have need to solve systems in 3-space in Chapter 7. And all of the problems that I've done, you're going to see in the homework. So whenever we have to solve a system for X, Y, and Z, look at your system. Hopefully I've copied this one correctly, and we just need to make a plan. So the thing that I see right away is that this first equation does not have an X value. So it would make sense to me to use equation 2 and equation 3 in order to cancel out the X's in order to get down to just Y and Z. So let's do that. So I'm going to take this first equation and I am going to multiply everything by negative 2 in order to have opposite coefficients on the X's. So that's going to be negative 2x minus 4y minus 2z equals negative 34. Then I will keep equation 3 as is. 2x minus 3y plus 2z equals negative 1. And it looks like some magic is going to happen here when I do a combination. Negative 2, positive 2 cancels. Negative 4, negative 3, negative 7y. A negative 2 and a positive 2, hooray, is 0, equals negative 35. How beautiful. Y is 5. So if y equals 5, and we already know that, we don't even have to make anything else cancel, because if we know that y is 5, we can plug it in here and solve for z. So let's do that. So 2y minus z equals 7. 2 times 5 minus z equals 7. So negative z equals 7 minus 10. Negative z equals negative 3. Z is 3. We know y. Now we know z. So let's go to that third equation. Let's plug in y and z, and then we can solve for x, and then our system is solved. So 2x minus 3y plus 2z equals negative 1. So 2x minus 3 times 5 plus 2 times 3 equals negative 1. 2x minus 15 plus 6 equals negative 1. 2x equals negative 2x minus 9 equals negative 1. 2x equals 8. X is 4. There's our x, there's our y, there's our z. Our solution for our system is 4, 5, and 3. So in addition to this introductory video, I will also post some other videos from some other amazing mathematicians from YouTube, but direct from my kitchen table, there is your Chapter 7 introduction.